Some time ago, I was speaking with a customer and they asked me how would CockroachDB handle thousands of requests per second to one single row? And at the time, I didn't have a good answer for them. But today I'd like to show you what this behavior looks like in CockroachDB and how you can mitigate it with follower reads. I'll spin up a Kubernetes cluster and install CockroachDB. And with that installed, I'll create a table to store products. There'll be an ID, name, and a price. And I've got an index on the name column. So in this scenario, we're an e-commerce business with a viral product. And then I'll start a workload. And the workload has started. I have 50 eager beaver customers, all desperately checking for the availability of a new product. And if we have a look at the UI, I'll go to the overload dashboard, where we'll see the CPU utilization for each of the nodes. And what I would expect to see is one of these nodes will show significantly higher CPU than the other two. And that's because of the way CockroachDB scales. Tables are split up into chunks we call ranges, and the one row that is in my table will be in one of those ranges. For this table, there are 3 replicas of that range, and one of the nodes will be nominated as the leaseholder for that range. And I can tell you already that the leaseholder for this particular row of data is node 2. That's showing higher CPU than the other 2 nodes, but they're all showing at least 50% CPU because the workload is busy and traffic is being routed to all 3 of them via the Kubernetes load balancer. However, the only way that nodes 1 and 3 can return their callers a consistent view of that row is by going via the leaseholder. I'll let that run for a few more minutes, and then the workload will automatically switch to use follower reads. It's worth noting that while I'm only seeing 500 requests per second, I've only allowed these nodes around 50% of one CPU each. And we're about to see the follower read workload take over. So that workload has finished, and now our follower read version has taken over. It's running exactly the same query, but this time using follower reads. And by using follower reads, our consumers are opting in to ever so slightly stale data. By default, this is around 4.5 seconds. But what this allows us to do is serve that row from any node that's aware of it. And because we're only running a 3-node cluster with a replication factor of 3, all 3 nodes are aware of this row. And that can be immediately seen in the UI. The CPU of node 2, our busiest node, has dropped right down to the same CPU load as the other 2 nodes. And that's because they're all now serving that row. This will continue to run for 5 minutes, and then we'll dive a little bit deeper, just so you can see what's going on. And both workloads have now finished. Notice that the average latency when using follower reads was lower than when we weren't using follower reads. And that's because we were no longer having to make an additional hop if a client request came to a node that wasn't the leaseholder for that row. I'll now run 6 requests against the database. This request targets CockroachDB 0, and it runs the same query that we ran in our workload without using follower reads. And in the explain plan, we can see that we hit node 1, but the data was served from node 2. We weren't using follower reads, therefore the data had to come from the leaseholder. If I make the same request again, but this time using follower reads, the SQL is executed on node 1, but we also serve the data from node 1. It didn't need to go to the leaseholder because we allowed it to serve data that was a couple of seconds out of date. This time we'll run the queries against CockroachDB 1, which is node 3 in the cluster. The SQL was executed on node 3, but the data was served from node 2. And as with the first node, as soon as we harness follower reads, the data is served from the same node that we hit. And finally, we'll hit CockroachDB 2. This is our leaseholder. If I run the statement without follower reads, we hit node 2, but we also serve data from node 2 because we've hit the leaseholder. And unsurprisingly, if we apply follower reads, we get the same response. This is a small 3-node cluster with a replication factor of 3, so data exists on each of these nodes. But follower reads might be useful if you have particularly busy rows or ranges. Think new product launches, cat videos, etc. If you have particularly busy rows or ranges and your reads can serve slightly stale data, follower reads might be a really good option to help balance CPU across all of your nodes.